Hello? Not quite as loud as Jashank. Hello, everybody. Hello, 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 enthusiastic hello. Sorry, what are you about to do? Yeah, ha ha ha, thanks. I gotta push that button. Sorry for the delay in getting started. There have been issues getting stuff set up this morning, so hopefully it should all be good now. But hello, welcome to week 11, Wednesday, COMP1511 lecture. Awesome. So today we're going to be looking at some very awesome things. We're going to be looking at stacks and queues, which are data structures, and ADTs, which are the most fantastic thing in computing. So hopefully that'll be good. I talked too fast yesterday because I didn't have my talk slowly sign out, so hopefully it'll be better today. But if I'm talking too fast, please just let me know. Just like look confused or wave your hands or something, whatever. So after today's lecture, you should have a basic understanding of stacks and queues, basic understanding of ADTs, and know the difference between concrete and abstract types. That will all make sense shortly. Admin stuff, assignment 3 is out. Hopefully you've started. How many of you went home and started the assignment by making a player name function? The rest of you are missing out. It's an easy way to start the assignment. Weekly test due tomorrow, Thursday, help sessions. Cool, life is good. So introducing stacks. Sorry. Stacks and queues are ubiquitous data structures in computing. These are Andrew Taylor's words on my slides. I apologize for that. That's a terrible introduction. Doesn't even say what stacks are. So stacks and queues are what we call data structures. Stacks are a way of doing a data structure. Did I say stacks? I meant structs. Structs are a way of doing a data structure. They're ways of sort of storing numbers, ordering numbers, I guess. A stack is a collection such that the last item to enter is the first one to exit. So we call them a last in, first out. So if you imagine like a stack of pancakes, for example, like you make a pancake, you put it on the pile of pancakes, right? You make another pancake, you put it on top, like, and so on and so on. And then you can't take the bottom pancake out because if you try, the pancakes will fall over. So you can always, the new things you add go on top, and then the first thing that you remove comes from the top, or a stack of books. We have sort of these stack operations. So the ways that we can refer to the things that we can do. We can push something onto a stack, which is adding a new thing to the stack. And we can pop something from the stack, so that's removing the top thing from the stack. Shooters, could you put my slides on WebCMS? Thank you. No, you can't. Okay, I'm sorry. I'm sorry, I'll put my slides up in the break. I saw people taking photos. Let's draw some pictures to explain this without pushing buttons. That one? Yeah. Cool. So when I talk about a stack, you can think of a stack of pancakes. I guess in C we would use a stack of numbers rather than pancakes because I don't know how to code pancakes. But the idea is, you know, with a stack of pancakes, you cook a pancake and then it's there, and then you cook another pancake and like set it on top and so on. Or if you've got like a pile of books because you keep on buying books and then you don't read them fast enough because you like buying books more than you have time to read them. Some of you will know that feeling. But conceptually, right, when you add a thing on, you add it onto the top of the existing things. And in terms of doing this in C with numbers, if we wanted to add the digits of pi to a stack for some reason, we can add 3, 1, 4, 1, 5. So the order that we add the things in, the one that was first is at the bottom, and then the one that was most recently added is at the top. So to add the next number here, oh man, it goes off the page. So to add the 5 here, to add a thing onto the stack, conceptually this is called pushing onto the stack. So I would say like push the number 5, and then that would put a 5 onto my stack. To get the 5 off, to get the top thing off, I would say pop. Yes, thanks for the sound effects. And so that would give me back the 5. So is this good conceptually so far? I have this thing, I can put numbers on, I can take numbers off. The last thing that I added is the first thing that comes off. Cool. And then we also have some other functions we can use. Top will fetch the top item, but not remove it. Size will give you the number of things, and isEmpty will tell you if it's empty or not. So for example, the size of this is currently 4, there's 4 things in it. If I call pop, it removes the first thing and gives it to me. If I call top, it doesn't remove the first thing and gives it to me. So it's like saying it's 5 on the top rather than saying, here's the 5, it's gone now. And isEmpty, this is not empty because there are 4 things in it. Cool. Applications you can use, you know when you have your history in a web browser and you view a page and then you can go back to the previous page, that are using a stack. So when you visit a new page, it sort of gets added to your history list, and then if you hit back, you go back to the one page you were on just before that, and so on. Various other things. But let's code this. If I can find VLab, yeah, VLab. Sorry, let me just check out what code I have. Yeah, okay, let's partially steal Andrew Taylor's code. So you should be able to see the lecture code. There we go, cool. In the usual place, you can see lecture code. There's a folder inside that called code, which is stuff you can't see. So you can see some code, and you can see a folder which you can't see. So just everything will be fine. So here is Andrew Taylor's implementation of stack ADT with an array. I guess before I get to this, how would we implement a stack? Right, we've seen arrays, and we could do this with an array fairly simply. Here's some array of some size. When I add a number, I just add it into the next spot in the array. So I know this is the next empty spot. So I go 3. And then because I've added the 3, this is the next empty spot. So it can be 1. So on this one here would be next empty spot, put the 4 in there. Next empty spot is here, put the 1 in here. And so then when I wanted to remove from the stack, I would just take this item that's here, give you, here's the 1, and then move the thing I'm up to be back to the 4. Cool. So that's how we could implement it with an array. But let's not use that code. I have a different keyboard that I can use. Excellent. So in order to make a stack, right, there are things that we need to keep track of. We need to have the array itself that the stack is in, like the array that is the stack. So this thing here. We also need to keep track of where we're up to, like where the current thing we've most recently added is. So that's 1 is the array itself, 2 is the up to place. Can you think of anything else we might need to keep track of? You can have a think about that while we start writing the code. So if I want to make myself a data structure, what do I need to use? Anyone? A struct, yes, to make a data structure, I need to use a struct. So struct, called stack. So I need to have an array. How big should I make my array be? 2, that's a terrible answer. I'm going to make it be max size. If you're asking yourself how big should my array be, the answer is usually make it be a hash definer and then set the hash define to be something. Because then someone else's problem. Int up to. And so up to will store the free space. Or the last inserted item. We'll worry about that in a second. Cool. So here is my stack. I need a semicolon there. I'll hash define max size to be 2048. Make it be 1511, much nicer number. Cool, so main function void. How do I make a stack? If I have this struct stack, how do I go about making myself one of these in the memory of my function? Yes, struct stack name. The name is going to be S because you use the name S for a stack, and it's a single letter variable name. That's bad, but whatever, it's a stack. Cool. And so now I have made myself struct stack S. What else do I need to do here? Can you think of anything else that I need to do? Can I just use this stack now? Let's hold that thought and see what DCC yells at us for, and then go back and fix it. Cool, so this is my stack. In order to access the fields inside my struct, I need to use the dot notation. So s.array will give us the array that we're storing things in our stack in. S.up to will give us the thing that we're currently up to. So this really needs a diagram. If you imagine, oh, that's not what I wanted. If you imagine this is like the memory of our stack. We have the array, and then we have the up to field, which is just going to be a number for which array index we're up to. To start out with, we would have this be zero, which is saying that the next free space you can put something in is the array index 0, that one there. And so if we wanted to add something new to our stack, we would go putting into the array in the index up to be our value, 3, for example. So does this conceptually make sense so far? I have a struct which contains an array of some size, and the index of the array that I'm currently up to, or the index that's the next free spot that I can put something in. I then, to put something in this, I look at, I'll grab a different color, like what is the thing that I'm up to? I'm up to index 0. So into array index 0, which is the first one here, I will put the number 3, for example. And so now my stack contains, well, one element, the number 3. What else do I need to do after this? I need to update something else about this. If I then wanted to add the number like 4, for example, right? So I go s.array s.up2 equals 4. What is going to go wrong here? Where is it going to put the 4? Yeah, it's going to overwrite the 3 with the 4, right? Which we don't want to do. So what do I need to do to know where the next free spot is going to be? Yes, increment up to. So I want to go, I've added this element 3. I want to make my up to be 1 more across. Come on. s.up2 plus plus. And so now s.up2 is going to be 1. The next free spot is 1. 1 second. I then say this s.up2 is 4, and so that will put the 4 into array index 1, which is that one there. Question? What a good question. The question was, is s.up2 automatically initialized as 0? I could either say yes or no, or I could say let's try it and see what happens. And I think I'll try it and see what happens because this is a thing that so many students have had. So I monitor the course forum, right? I have no life and no hobbies and like no friends. So all I do is like answer things on the course forum. How many of you have like read my answers, the really long ones, and thought this is kind of cool? Cool, I'm not wasting my life, thank you. But we get a lot of the same question over and over again. And often it's things like, I have this error saying uninitialized variable in the auto test, but it works fine when I run it myself, so the auto test must be broken. If you think the auto test is broken, like if you think it's giving the wrong answer, then maybe it is. If you think it's broken because it says your code is broken when it's not, your code is broken. Like, one time in my life I have seen a bug in DCC. Was very recently. Generally, if your code doesn't work, the compiler is not broken. Your code is broken. People like to say, oh, the compiler's broken. It's your fault, I'm sorry. So, for some reason when it lags, it does lots of letters. dash O, what have I called it? Stack array.c. It compiles. Good start. There we go. So runtime error index negative is out of bounds for type int 1511. What does this mean? Like, first of all, what is this error telling me? What am I trying to do? Yeah, I'm trying to access a negative array index. I'm trying to access array index negative really big numbers. So like if this is my array, I'm trying to access all the way over there like in lower campus in like anti-parade or something. But my array is here, so that's not valid to do. And so the question that was asked was, is s to up to automatically initialized to 0? No, it's not, because we're getting this error here. Let's do that. Cool. And so how do I initialize it to be 0? I can do this, right? S dot up to equals 0 to start it out at 0. There's also a nicer way that I can do it where I don't have to manually like say this or then have a loop to initialize all of the things to 0, right? Because if I wanted to set everything in the array to 0, I'd have to make a loop that goes through every single array element setting it to 0. But there is a cool thing that you can do, which is this. So say struct stack s, so s, which is a stack struct, is equal to squiggle brackets 0, and this will set everything in the struct to be 0 to start out with. And so if I compile this, someone said double curly brackets, but it's just one struct. But the struct contains an array. Does that mean I have to do double curly brackets? Okay, I'll do it. So the error I'm getting here is warning suggest braces around initialization of sub-object. What that actually means is put an extra set of squiggle brackets around the 0 that you have. I didn't think that I needed 2 sets for this, but maybe I do because I have an array inside my stack. Cool, no compile errors, code must work. And so now when I run my stack, nothing happens because it doesn't crash, right? All very interesting. So I have to do it because the first element in my struct is an array. Yes, that makes sense. Yeah, cool. I don't need to use the double squiggles. So I've written some code here to manually add things. It's kind of gross. Let's put it in a function. In order to not forget my function prototype, I'm going to write that first. It's this fantastic idea I've had. I'm going to write the prototype first, and then I won't forget it. So if I want to add something to a stack, I said that was called push, right? So if I'm pushing something onto my stack, what do I need to give it as input? Yeah, the stack itself, struct stack s, and then also the value to push on, right? Int value. Cool. And what type should this return? If I'm pushing something onto the stack, do I have to give you any return value back? Yeah, void, because I don't have to. I'm just modifying the stack itself, but I'm not actually changing. I'm not giving you any information back. Cool, and now that I have not forgotten my prototype, let's write the code for this. Excellent, and so I have my stack. I want to put something onto the stack, so I'm just going to copy this code here. Cool, so to put it onto my stack, I go to the array field, I go to the up to thing, I make that be equal to the value. What? Equals value, and then s to up to plus plus. Cool. There is a problem here. Does anybody know what the problem is? This is sort of like a tricky thing with stacks that you might not have noticed. When I call my push function, what input is it given? Like I'm giving it a, come on. I'm giving it a stack and a value, right? So I'm saying here is my stack, has an array and it has an up to, and put the value 3 into it. So this is like the function memory of main. It has this struct. And then when I call the push function, in its function memory, it gets a copy of the struct. So it gets this entire struct copy it into it. And so when I change something in this struct here, it's going to change it in here. It's not going to affect the one up here. So I need to pass a pointer in rather than passing in like the actual stack struct itself. And the nicer way to do this is to actually have like a new stack function that will just malloc a stack for us and give it that. So it'll give us a pointer automatically. So if I want to have a new stack function, it's not going to take any input. It's just going to give me a stack. What return type should this be? Struct stack star. So it's going to give me back the address of a stack struct. Cool. How do I malloc something? Struct stack star new equals malloc. Yes, very good. I start by saying malloc. What input type? So what input does malloc take? I give it a number. What should that number be? Yes, the number of bytes I wanted to allocate, which in this case is size of struct stack. Cool. So I have malloc to my thing. If I just return this now, return new, have I initialized my stack to be 0, to be all zeros? No, I have not. So bad things will happen. So in this case, I want to say new arrow up to equals 0. Does it matter whether I initialize the actual array inside the struct? Do I need to initialize all that to zeros or not? Because I know a lot of people with the way of the struct thing, they were saying on the forum, like, so do I have to initialize every single thing in the whole array of structs, even if I don't use it? And the answer is no, you just have to initialize the things before you try and like read from them or use them to do something. So in this case, even though the array will be full of random stuff, it doesn't actually matter because we're going to put a value in there before we use it, right? So this is full of whatever random values happen to be in here. But when I add a new thing to my stack, I'm going to put a number in here rather than just trying to access that field. So I'm always going to put something new in before I try and get something out. Hopefully. I don't have to. Cool, so this will make me a new stack. Struct stack star s equals new stack. Excellent. And so now if I want to push something onto my stack, without forgetting my function prototype, if I want to give this the stack that I've made, like I don't want to actually give it a concrete stack, right? I want to give it a pointer to a stack. So I just put a star in there. Whoa, this one here. And so now what I'm saying is give it the memory address of the stack so that it can go to that thing in memory and change the values in it. Awesome. Full screen this. So what do I need to change in my code down here when it wakes up? What's the difference between accessing a struct and a struct pointer? I'll give you a clue. One possible answer starts with S, ends with tab, and is not the answer that I like. You've got to change the dots to arrows, right? When we have the dot syntax, that's saying get this field of the struct. But because it's a pointer to a struct and not a struct itself, we have to say go to the struct in memory and then get its field. So we use the arrow to show that. Cool, and so now hopefully this will take in our stack pointer, take in some value, and put that onto the stack. Cool, that's all good so far. So now I can go push onto my stack, giving it the pointer to the stack and the value. And I will do this with an actual keyboard. Cool. 3, 1, 4, 1, 5. And so at this point here in the code, what should my stack look like? Like what will be on my stack? If I've pushed on 3, 1, 4, 1, 5, is my stack going to look like, I'll do this thing. Is it going to look like 3, then 1, then 4, then 1, then 5? Or is it going to look like 5, 1, 4, 1, 3. Cool. The second one, because when I add something to my stack, it goes to the bottom of the stack, right? Like when you add when you cook a pancake and take it off and put it on your plate, it's on the bottom of the plate. Then when you make a new pancake, it goes on top, and so on. So the top thing in my stack is going to be this 5 that I have just added. Cool. Why is this mouse not working? What happens if I steal this mouse? Aha, that's better. Heaps better. Cool. So at this point, my stack has 3, 1, 4, 1, 5. And in terms of the diagram that I had, the actual array, any moment now, VLab, is going to look like, here is my struct. Inside the array, I have 3, 1, 4, 1, 5. And my up to field is going to be, which value should it be? What is the field that I'm up to? What is like the next empty space in my array? What index is that? 0, 1, 2, 3, 4, 5? Hopefully. Cool, and I mean, let's just print that out and see, right? S up to is up to, why am I using that keyboard? Cool, so let's compile this. Have I forgotten any function prototypes this time? Hopefully not. Come on. I've forgotten my hash includes. It's just as bad. So I need stdio for printf and stuff, and stdlib for malloc and stuff. Compile again. Ah, I forgot a comma in my printf. Cool. Compile again. Yay, compiled. There must be no bugs in my code. Cool, and so it's run the code. Can I shrink that window back? Oh, why are computers so hard? There we go. So I've run my code. It's pushed on 31415, and it's told me S error up to is 5. Just to make it clear, I'll change it to be like 6 to show that it's not the value, it's the index. DCC. Cool. Does this all make sense so far? I've made myself a struct. It contains an array which has some number of items that I can put into it. I'm putting items into it. As I add an item, I'm putting it onto the end of the array, or like the sort of next empty space in the array. And then that's sort of the one that I'm up to. So when I take something off, I will take it off from there. So let's make a function to do that. So remember, I said before that pop was the name of the thing that would give me an element back. It's not going to take a value because it's just giving me the first element, but what's it going to return? If it's returning like the next value in the stack, what type are our values? Ints? Yes, great answer, everybody. I don't know why it does that. I think it must be because VLab lags. Cool, int pop takes in my stack. So this will return, I'll check a comment here, or not. Cool. So to pop something from my stack, what's that going to look like? What are the 2 steps I'm going to have to do? If I unfull screen this and get my thing. So if currently the last thing on my stack is the 6, and I want to give the user back the 6 and then also remove the 6 from the stack, what do I need to do there? Up to is 5, so up to is currently pointing to this element here, this gap. So how do I access this one here? Yeah, up to -1. Up to is the next free space, and so the latest element is going to be the one before the next free space. Cool. So the number I want to return is going to be my S at index S up to -1, so S array S index, like that. And then what else do I need to do? So when I've removed it from the array, how do I know that I've removed it? I've got to change my up to, right? And also not drop this keyboard. So S up to -. Cool. Return value. Is there a way that I can simplify this into fewer lines of code? The thing that I'm doing here, can I just get this one here open? Yes, I can. Cool, that will do. So I've got my stack, so my array that looks like this. It's got some number in here, it's a 6. Up to is currently 0, 1, 2, 3, 4. So up to is saying the latest free element is 4. And so I want to get this 6 here and say, okay, return the 6 to the user, and also remove the 6, which means I'm going to have to say the one that you're up, like the next free space is the space where the 6 was. If that makes sense. So I'm saying up to is going to be 1 less than it was. So like this is the next free space. So you can overwrite the 6 with the next value that you add. So the way I'm doing that right now, I need to turn this off. The way I'm doing that now is I'm saying the value is the one that's before up to, before the index up to, and then decrease up to. But I could simplify this by moving it this way around. And so if I decrease up to first, and then I can just say S error up to, if that makes sense. And then I could even just return that. Cool. So does that make sense? I'm making my up to be back 1 from where it was. So if up to was currently this one here, I'm saying, okay, now you're up to this one here where the 6 is. So the next free space is where the 6 is. And then I'm saying, and by the way, the value that you asked for from the top is the one at this new up to, which is 6. Cool? All good so far? Cool. So let's run this, push some stuff, S up to is this. Actually, let's make another function that will say if the stack is empty. So this function should return true if it is empty and false if it's not empty. So what would that function look like? How do I know if my stack is empty? Thinking back to this example here. If it's empty, then the current next free space is going to be this one here, right? Yeah, like you were saying. So if up to is 0, then the stack is currently empty. There's nothing in there. So we can say if S error up to 0, I mean it's empty, else it's not empty. But I don't need to have this if-else statement here. I can just return S error up to equals 0, as in this. And so this will implicitly return true or false. It's like if this if statement condition is true, then it's empty. So we'd say like return true or whatever. And otherwise it's not empty, so we would return false. So by returning the if statement condition here directly, we're basically saying return whether or not the empty value is equal to 0. Comment that there. You have to type shift. That'll do. Cool. And so this will tell me when it's empty. And the reason I wanted to do this is so I can just have a loop that will pop all the values off. So while something, cool, typing, it's a thing that I can do. So I want my loop to be like, while there are still things in the stack, pop the next thing from the stack and print out what it was. So if I want to keep going until the stack is not empty, how would I do that? I can call my isEmpty function, right? Give it my stack. So this will return true if it's empty and false if it's not empty. So that's sort of like the opposite of what I want. I want to go until, I want to keep going as long as it's not empty. So as long as isEmpty gives me false. And there's a convenient syntax for this, which is the exclamation mark or the not operator. So this means while not is empty, yes. So while is empty inverted. So if it says that it's not empty, so like not is yes, if that makes sense. So that was pirate, apparently. Thanks. tcc.stack. Cool. So we can see pop gives us 61413. So we put it on an order 31416, and then we took it off an order 61413. Cool. Is this all good? Are there any questions? Cool. What is the time? 3 o'clock. Do you want to have a break now, or do you want to have a break shortly? There's sort of another thing I want to do, and then like an obvious good spot for a break. So are you okay to keep going even though it's 3 o'clock because we started late? Does anybody want to break now? Does anybody not want to break now? People who want to break, you're outvoted, I'm sorry. If you need to leave because you have a clash, just leave. It's fine. I won't be very sad if you walk out partway through. Like, I'll be a little bit sad, but you're welcome to just leave. Cool. So, do my slides have the thing that I want to have next? Not quite. So pretend that I didn't have those slides there. So we can make a stack with an array, right, as we've just seen. The problem with making a stack as an array, well, what is a problem? Like, why is it bad? What could be bad about having an array to make our stack? Yeah, limited length. Is that what you were going to say? Yes. Yeah, so you need to know the maximum size, and then you can't increase the maximum size. So once you've made your stack of fixed size 1511, you can't have more than 1511 items in it. And so we can get around this with a linked list, right? By going, okay, here is our linked list, so we can just always add another node on another node, another node on the end. So we can have it infinitely long, where infinite is whatever fits in our memory of our computer. And then we don't really have this max length concept, because as long as we can still malloc something, it's fine. We can add anything onto our stack. Haven't talked about queues yet, ignore that. So if we cool. These slides totally make sense to me now. So if we have our stack as a linked list, so if we're pushing on, I'll start in the middle. If we're pushing on 3, and this is like the head of our list, or the start of our list, if I want to add like the 1 in front of the list, or sort of on top of the 3, how would I do that? Because normally with lists, right, we like make the 3, make it point to the 1, make it point to the 4, and so on. We sort of add things along and along. But if we want to always add to like the front of the list, we need to make the new thing that we add. So the 1, for example, should point to the current stack, the rest of the list. And then that becomes the new start of our list, or the new start of our stack. Does that make sense? So we're always adding onto the start. So we'd add the 3, 1, the 4, head would now point to this one here, and so on. All good? Cool, come on, unfull screen. Undraw, unfull screen. VLab. Cool, so that one can go away. Save as stack list. Cool, so if we're going to have a linked list rather than an array, we're going to need to have struct node star head, front, top, whatever you want to call it. In order to have a linked list, we need to have our list struct, right? So that was struct node. Cool, so this is our linked list struct we've seen before. We can have a pointer to the current top of the stack. Do we need an up to? We don't really need an up to because we just know that it's this current thing here. Cool, to make a new stack, is that going to be the same? Do I still just go malloc size of struct stack? So yes, but I don't need to set the up to anymore. Cool. To add something onto the stack now, rather than adding it to the next up to thing in the list, I'm going to make a new node with value, and then add that to start of list. Cool. So to make a new node, new node value. Let's just hash include list.h. Cool, and now someone else has written the list stuff for us. Could even get rid of that. So we can call our new node function, it'll give us a new node. To add that to the start of the list, remember I said we've got to add it in front of the current thing. So node arrow next is going to be the current start of our stack. Cool. And then I need to update start of list. Cool. So does this make sense? In order to add it on, I need to clear all that. Make a new node with a value. So if my stack is currently just the 3, to add the 1 on, I need to make a new node that has the value 1. I need to add that to the start of the list by saying this is now the new first node, so it points to the 3. And then I need to update the start of my list is now this one here. All good? Cool. So this will add something onto our stack. How do we pop something off? Rather than just moving the up to backwards along our array, we need to do something like get the value from the head of the array, of the list. So how do I get the value of something? If the list is s arrow head gives me that node that's on the top. To get the value out of it, I can say arrow data. Yes? No? Yes? Cool. Then I need to make it point to, remove it from, this needs a picture. Delete this. So I have my 3, and then I have my 1 that I've just added. So the 1 points to the 3. And S arrowhead is a pointer to this 1. So I need to keep track of this 1 value that I'm going to return. Grab a different color. So I need to go by the way, the 1 is the number that I'm going to return. I then need to update where the head points, because the new start of the list is going to be this one here, right? Because we've gotten rid of the 1. And then I need to also free the node 1, because otherwise I'm a bad person who hasn't freed my memory. So I need to go like do S arrowhead, S arrowhead, arrow next. So that's going to move S arrowhead to be the thing that S arrowhead's next pointer points to, which is like this arrow here, which is this one here. And then I need to free that first node. But how do I do that? Because if I did that, I'd be freeing the node that I've moved it along to. So what am I going to need to do here? If I've moved my head along to point at this 3, I can't now free the 1, right? So I need to keep track of it somehow. Yes, agree? Make a temporary pointer to a node? Yes, correct answer. And so I need to keep track of it so I know how to get to this thing once I've, come on, moved it along. So struct node star temp equals, cool, and then free temp. And so in terms of the diagram, this looks like I've gone S arrowhead now points to this 3. But first of all, make temp point to this 1 here, so that once this pointer here is gone, we can still free this 1 because we still know how to get to it. Cool. So that's push, that's pop. Int is empty. How do I know if it's empty? Delete all of this. Which thing will tell me if my list is empty? What is an empty list, conceptually? What would my node pointer point to if it was empty? Yes, null, exactly. Null is sort of the way that I explicitly say this is an empty list. So that means I will need to set my head pointer to be equal to null when I start out to say, hey, this is an empty list. And then I can just return, come on, S arrowhead equal to null. And so if it is equal to null, it's empty, and if it's not equal to null, then it's not empty. Cool. I don't think that should say clear while not is empty. Okay, shall we see if this compiles? List.h not found. Cool, now I have my list.h and my list.c. I can't print out what it's up to because there is no up to field. Cool, will it work this time? So I've got two problems. 61 is saying I don't return anything, so I should return the value that I've popped off. But I'm also getting this error, something, 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 something linker. So what does it mean if I have a linker error? It could mean that there's an angry shooter. Yeah, Alex Linker is one of the tutors. Probably they're not giving an error. So when we get a linker error, as opposed to a compile error is when you have a bug in your C code, like a syntax error in your C code. A linker error is when you don't have any bugs in your, any syntax errors in your C code, but you haven't given it all the functions it needs. So you'll see this if you name your function the wrong thing for a weekly test or whatever, you'll get this sort of error. But in this case, it's saying I don't actually know what this new node function is and all this list stuff is doing. So I have to also give it list.c so that it also has the code from list.c to compile together. And that compiled, and now I run it, and it does exactly the same output as before, and I even compiled the right file so you can believe me that it actually did something. Cool. Does that make sense? I've got a different implementation of my list, of my stack. I've got one version of the code that uses an array. So it's got this struct stack internals. That's what I was supposed to call it. oops, whatever, struct stack, which has an array and an up to, and all these functions here which will push and pop something by working with the array. And I have a list version of my stack which will do all of the same function prototypes, and it's the same way to use it like this, except these functions that actually do the work when it scrolls work with a linked list instead of working with an array. Is this all good thus far? Cool. Let's take a break. I'm going to cheat you out of a 10-minute break and give you a 7-minute break, because you sort of had a break at the start, whatever. So 7 minutes. Okay, is that enough beeping? Will you be quiet now? Hello again, everybody. Hello again, everybody. Hello. I hope you had a good 7-minute break. I hope it was very breakful and restful and so on. So, I've had 2 very good questions over the break, which coincidentally I'm about to answer now anyway. I'll just repeat the question so that you can feel like I've answered the question when I answer it later on. So one thing is sort of like the difference between these implementations, and by implementation I mean like the way that the code is written to achieve a certain thing. The difference is in what is inside the stack struct. So for the list version of my stack, I've just got a pointer to like the first node in my list, or the current head of my stack. Whereas in my array stack, the struct itself contains different things. So the struct itself, nope, Andrew Taylor's one. My one is over here. Maybe. The struct itself contains different things, and this one, it contains the array that it's up to, and the array, and then the position that it's up to, the next free position. So the implementation is different. So this struct contents are different, and then the way that the functions work are different. And I had a really, really good question, which was like, why, really important question coming, what's the point? Why do we do this? We could just say, pass in the array and the up to a function, and that function could use those directly rather than having to use a struct. And so we wouldn't have to use a struct, it'd be great, we could just have some numbers, give it the numbers, give it the array, get them back, life is good. And the answer to that is, should I give the answer away now? I'll give the answer away in a minute. So think about the question of why is it useful to have this struct rather than just giving it directly the array and the up to? And I will launch into a seemingly unrelated discussion. That's the spoiler. So a brief aside, USB devices, right? Like I have a USB mouse, plugs into a USB slot, I've got like flash drives, I've got various things. All of these USB devices, they share a common interface is the word that I would use. So when you have a USB device, it works in any USB port. Like you're probably too young for this example to like be meaningful anymore. How many of you have had to install a device driver? Cool, not none of you. So do you remember the good old days before we had USB when you had to like get the specific serial driver for your serial mouse? And is anyone that old? A couple of people, okay, I'm glad. So back when I was your age, back when I was a young lad, you couldn't just go, I have a USB mouse, I'll plug it in, it works on any computer with USB. You had to sort of, the person making the mouse had to specifically write a driver, a program for the computer to know how to use the mouse, and so it all had to be, you had to do a lot of specific work for how your specific thing worked. And then along came USB, Universal Serial Bus, which took away all the, you don't need to know how it works now. You just need to know, I have a USB device and it's a mouse, and so it's going to have like these mouse-related functions that it will implement, and so it'll be like if you move left, it'll say I've moved left and right and so on. Like it conforms to this sort of standard definition of this is what a USB device should do, and now you can just plug in a USB device and you just have a mouse that works. And I'm sure many of you don't actually appreciate how fantastic that is. It's fantastic, just you can believe me. And this is an example of what we call like an interface. really important thing here. This is what we'd call an interface, which is, I guess, a way of defining how you can interact with something. And so in the case of a mouse, there's whatever, things, and it's the rules for how you can code a mouse, and both sides talk the same thing. In terms of our stack we've defined the rules of how you can interact with a stack, right? We've said that you can use this push function, you can use this pop function. You could also directly use the arrays and stuff, right? Like you can have this file and you can say, rather than pushing something onto the stack, you can say yourself like, s arrow array s arrow up to equals whatever value. You can interact with directly yourself. You can take this thing and change things inside the struct. So you can go, oh yeah, this is an array-based struct. I'm going to change the things in the array like this, right? And I mean, similarly, you can pass an array into the function and pass the up to into the function, right? And you can say, here are the values directly. But that means we're stuck to this implementation. If I have a stack that I've made with an array, and I've told you the struct looks like this is how it works, you can access this field of the struct to do this. If I have told you that, then I cannot change how my code works. If you know how my struct looks, how it works on the inside, I can never change that. I have this contract with you. I've said, you can use my struct. Cool, here's how it works on the inside. Here are the fields. And then I can't just say later on, oh, actually, it's going to be a linked list now because you've got to change all of your code. Right? Like if you think about, Facebook Messenger, and there are like bots for companies, and so you can message the company and it'll reply with whatever generic company things. Have any of you, do you know what I mean when I talk about like Facebook bots? Not very many people, or any sort of service, Facebook bots, Twitter bots, something where, lots and lots of companies have a thing and you can message the company on Facebook. And they've written some code that will say, like, if you've messaged about this, then it'll send you to this track and so on. Now, Facebook has what's called an API, an application programming interface, which I briefly mentioned yesterday. Facebook defines the rules for interacting with it. So Facebook says, here is a function, and this function will give you the unread messages you have, or this function will send a message to someone, so you can go like, give me the latest message, and I'll have, if it's got this or whatever, then send this message, right? So Facebook defines, these are the functions that you can use to interact with Facebook. And so Facebook are free to change how their system works in the background. If they have said, this function here, you give it your username and password, and it will give you back the latest message that you have. You have that, like, the only way you can do this is through that function. So you don't need to know how it works on Facebook's end, and they don't need to tell you, right? And they can change their entire database structure and everything and how they store things, and your code will still work because you have that interface. You have this sort of, here is what you're allowed to do, and I promise that you can still use it in the same way, but I'll change how it works on my end and you won't know. Does that make sense so far? Person who asked the question, have I convinced you? Whoever they were? Maybe they're not here anymore. Maybe they just got bored to tears by my beautiful explanation. And so we do this in programming with things called abstract data types. And so we say, like, here is a stack, and you can make a stack. You can use the new stack function to make a new stack. You can use the push function to add something onto the stack. You can use the pop function to get something off the stack. But you can't actually access the stack yourself, the stack struct yourself. So you can use these functions that I've given you, but you can't actually directly interact with the struct. And we'd call this an abstract type. Abstract in the sense that you don't know how it works. You can't see inside the struct. You just know that it will work if you give it these functions. So you can call this function and it will give you back a stack. You then don't know, like, you can't see how the stack works, but you have a pointer to the stack and you can give that to the push and the pop functions and so on. And so we call that an abstract type, or an abstract data type, in this case an ADT, because then we can change things behind the scenes, and because you're just using these functions to interact with us, you can't tell that it's changed. And so, yeah, a concrete type, if you can see the struct in your program, so like in the list.h, we have the list struct, right? So anyone who hash includes list.h can make a linked list and can directly change the node, the pointers, the values, and so on. Yeah, and so you can't change the insides of the type of a struct without breaking software that relies on it. So we couldn't say, you know, here's a struct that makes this stack using an array. It's all great. You make your code to actually directly access the array indexes and stuff. And then I go, oh, but people's things need to be bigger now, so I'm going to use a linked list instead. But that breaks all of your code. Cool. And so the way that we can do this, you need to know about the type. You need to know that there exists a type that is called struct stack or struct stack internals here. But we don't have to actually give you the struct itself. So if I have this line in my .h file or in your code, typedef struct stack internals star stack. Have we seen typedef yet? We have seen typedef? Cool. Because normally we do it for structs, all structs, but we haven't yet. So this is saying, when I say struct stack internals star, I mean a stack. Let me try that again. When I say stack, I mean a pointer to a struct stack internal. So I can use the word stack to refer to this type, pointer to struct stack internals. And so if you have this type def, like in your code or in a .h file that you're including, you can refer to the type stack. You don't have to know how it works. You can't see inside the struct, but you can refer to the stack without knowing what's inside. You can't dereference it, so you can't go like stack s and then s arrow something. That'll be like, you can't dereference it, I don't know what's on the inside. The compiler will complain. But you can pass around this pointer in the system. Yes, and that's called ADTs. So I didn't really make my stack code not, come on. So because I'm already using functions for this and I've just changed the implementation of my functions, like there's no visible difference to you when you use my code. If you're just using the functions, then it's fine. But you could still be a bad person and directly reference the fields. So let's call it stack. Come on. Good computer. Nope. Stack user, and so this can be a person who uses the stack. I'll need to put all of the stuff that's in common into stack.h so that it can actually access these things. And so I can say like struct stack start s equals new stack. And then because I know it's an array-based stack, I can go like s arrow array s up to equals 5. And then if I go pop s, this will give me back the 5 that I just pushed on. Right, hopefully. Oh, chuck that one there. Okay, get rid of all of this code. So if you weren't here yesterday or you weren't paying attention yesterday, we looked at .h files, which are this one here. Where did all my prototypes go? That's Andrew Taylor's code, not mine. Try that again. Cool. So we looked at .h files, header files, which are, we can take some code out of our C file, and then when someone hash includes this header file, they get that code sort of for free. So we can put our function prototypes in here, and then anybody who hash includes that can call those functions in their program. Stack.h. Is VLab lagging for anybody else? Like, does this happen on your computers? No, never at all? Okay, that sucks for me. I don't know what's happening. Like, maybe uni-wide's just really laggy, but then, come on. If I like stand here and look disappointed, will it go faster? Cool. So I have all my hash defines, I have all my structs, I have all my function prototypes in here. I also have the thing called a header guard, if and def stack_h. And this just means that if you hash include this in one file and another file, you compile them both together, it will only actually have the code for this happen once. So if you're doing things in here that need to only happen once, you need to have this. And if cool. And so now open stack array, cool. Can get rid of all of this. Hash includes stack.h. And so now my stack array thing will work exactly the same. I've just moved all of the prototypes and stuff into this header file. But now my stack user can also use those functions. So in theory, if I compile this, stack user.c stack array.c, the typo that happened. Did I call it is empty? I did, awesome, cool. Multiple definitions of main. Someone asked us on the forum yesterday, like, why did I have to rename the main? Because you can't have more than one main function. You can't have more than one function with the same name anyway. But if I have two main functions in my code, like where does it start, right? When it starts the program by running the main function, which one does it choose? It doesn't know, so it makes me only have one. 23. It's now a normal int function, so it wants your return value. Cool, it compiles. Clearly there are no bugs in my program. Oh man. That's bad. So what's happened here? I've got runtime error index -1 out of bounds for type int 1511. So I've tried to access like field -1 of my array. S.up2 is -1. So when I'm trying to access array -1, it doesn't work. Come on, don't lag. Do you remember yesterday if it got less laggy when I crashed and then uncrashed? Was it less laggy after that? Does anybody remember? Okay, if it keeps lagging, I'll just switch to a hotspot and then everything will break again and it will be great. Okay. No, this is just not happy. Okay, talk amongst yourselves for a few minutes while I'll ponder the joys of modern technology. Do I have to properly exit VLab? Maybe. Can anybody else not connect to VLab? Everyone's on VLab, it's just both of my computers. Aha! If it doesn't work at first, then try again many times. Does anybody know if there's a way to like automatically get my windows to move to the right place? Because that sort of thing would be very convenient. Okay, where were we? Sorry for that. Computers are hard. No, not that button. Okay, here's where we were up to before. It gave us an error and we didn't know why. Come on, computer, you can do it. Okay, cool. So now that everything is back and working again, get to put up with me talking again for some time. Yay, life is good. So we can see the problem we have index -1 out of bounds for, it's gone off the end of the page, trying to access my array. What has happened here? I'm trying to pop from an array down here, right? But because S arrow up to is -1, so it was 0 here and then it became -1 here, I'm trying to get -1 in an array, right? And so I have found a bug in my program. How would I fix this bug? Or what, more specifically, what is this bug? If the stack is empty, can I pop from it? No, I can't. And so the problem is I am trying to pop from it if it's empty. If is, let's do even better. Let's assert not is empty s. Must not be empty. Cool, so I've just added an assert here, so I'm basically saying you are not allowed to call this with an empty stack. And if you do, it's your fault and you've broken it, and it'll crash the program. So now we should get hash include for assert. Cool, clear./stack. Cool, so now we've failed an assertion, so we've still got the same sort of error. Still doesn't work, but we've been told that you're not allowed to have it be an empty stack. Right, and so the problem is that the person using it here is very silly and didn't go s0 up to ++ like they should have done. So this is one risk of trying to use code directly. You make bugs. ./stack. Cool, and so we have seen we have now successfully added 5 to the stack ourselves and popped off the stack, and this works. We can do this and everything is fine. And then let's also do push S5. So I'll do the same thing here, except I will do it using the proper functions as well. Cool. So it works both times. We add on 5, we pop off 5, life is good. But if I change our implementation now, so if I go, instead of stack array, I want to use stack list. Still compile. And I have to tell it about list.c as well. Still compiles. I need to also not have a main function in this one. It still compiles. It still compiles, but now when we run it, we're going to have problems. We're going to have a bad time. Illegal array pointer or other operation. We're trying to go s arrow up to equals 5. We've made a stack. So we're inside stack user. We've made a stack with the new stack function. That is inside stack list.c. So if we look at the new stack function, it's given us a struct stack, right? And so we have a pointer to this, and we're trying to get the array field out of this struct. Does this have an array field? Is there an array field in here? Hint, the answer is no. No, there's no array field. So I can't try and access the array part of the stack because I've changed it to a list now. There is no array anymore. And so because this naughty user here is trying to access the struct directly, they will fail. But if they are being a good person and using the struct through the interface functions, through the things that we've said they are allowed to use, then there's no problems, right? So if you assume that the stack is being compiled with stackarray.c and you have the array stack and you can change things, you're going to have a bad time when you're no longer using that, when it's now the list stack. There's a way that we can enforce this. We can sort of enforce that people do not do these bad things. And that is by not having this struct inside the .h file. And so instead, I need to have a type def so that it knows about it. Because if I don't have the struct anywhere, it'll go, what is the struct? Struct stack, star stack. And so what this says is when you see a stack, a type that's literally just called stack, it's actually a pointer to a struct stack. I'm not going to tell you what a struct stack is, just that it's a pointer to it. So you can know it's a pointer to it, you can pass it around, you can't see what's inside. So life is good. Maybe. Cool. Still compiles, still runs, everything is good. And if I put this array stuff back in here, rather than it running and crashing, it should, hopefully, give me a compile error. Clear. Cool. So this error here, this is an important one to notice and know about. Error incomplete definition of type struct stack. And so what this will probably mean from now on is that you have an ADT, you have an abstract data type. So you have a type def of the type, but you don't actually have the struct of that type. And you're trying to use it despite not knowing what that is like. So because you can't see the struct itself. This might need a diagram, actually. Squid. New note blank. So if you think we have our, this was called struct list.c. And this contained, no, it was called stack list.c. Right, and this contained our struct stack, which is like the node star head. Yep, my writing's so great. And then this has the actual functions. We then had struct.h, which had the type def, and it had the prototypes. Yep, totally readable. And then we have stack user.c, which just calls the functions. So because struct.h has the prototypes of these functions here, anybody who's included struct.h can use these prototypes. So if we have stack user hash include struct.h, right, this can now see all of this stuff that's inside struct.h. So it can see the type def, it can see the prototypes. Because it has the prototype, because it can see the prototypes, it can call the functions. It doesn't know how the functions work. Stack user.c has no way to see inside this one. Like it can't see what's inside stack list.c. Like if you are in a file, you cannot see what's inside another file unless you've explicitly made it global. So when you're inside a file, you can't see the things in another file. You can call the functions if you have the prototypes. If you don't have the prototypes, then good luck, you can't call the function. Maybe you can, you should be able to. But importantly here, because we don't have the stack, The struct, sorry, because the struct is in this .c file. When we're inside stack user.c, we can't see the stack. We can't see the actual struct that contains the pointers or the arrays or whatever. We can see the type def of it, so we know that there exists a type. We know that there exists a type struct stack star, and we have a pointer to it. But we can't actually see how it works. Does that make sense? So this is like a really important concept to get. When you have multiple files, they can't see what's in each other's file. If you give them the prototypes, they can call the other functions. But if you have a struct inside one of your files, you can't see it in another file. Cool. Does that make sense? Yes? No? Yes? Oh, my slides are closed. Well, it is 3:55 anyway, so I think that is it. Let me open my